All right, we're going to start our lesson exploring the opposite sides of parallelograms. So the question we're being asked is, how do the lengths of the opposite sides of a parallelogram compare to each other? Well, first of all, let's focus on the fact that we're talking about a parallelogram. So parallelogram, by definition, it's a quadrilateral where opposite sides are parallel. So what does that mean when you have opposite sides? Well, let me tell you, that is some exciting things. So opposite sides are parallel. So let's take a look at BC. Side BC is parallel to side AD. And what does that do for us? So here's BC parallel to AD. If we think about extending sides BC and AD just a little bit, what we notice is that this BD going that diagonal is a transversal of those two parallel lines. So if BC is parallel to AD, that makes segment BD a transversal. So do you guys remember back in Geometry A when we had parallel lines cut by a transversal? So if I take a look at the parallel lines cut by the transversal, which angles are formed by the parallel line and the transversal? So here's a parallel line, here's the transversal that's forming angle 2. Here's the other parallel line with that same transversal, that's angle 3. And that angle pair is going to be congruent. Those are alternate interior angles. They are interior inside of your parallel lines, and they are on alternate sides of that transversal. So we know that angle 2 will be congruent to angle 3 because they are alternate interior angles. So are those the only parallel lines we have? No, they're not. We've got another set of parallel lines, or parallel sides, excuse me. We also have side AB that is parallel to side CD or DC. So let's take a look at those parallel lines. If we go back to our picture, let's extend side AB so it just kind of looks more like a line. Extend side DC. These are parallel. That BD, again, is a transversal cutting through parallel lines. So when AB is parallel to DC, that makes BD a transversal. And when you have parallel lines cut by a transversal, you create angle pairs, and a lot of these angle pairs will be congruent. The other angle pairs will be supplementary. So let's take a look at what angles are formed by our parallel lines and the transversal. So if I go over here where the parallel line and the transversal intersect, I can see they are forming angle 1. If I go to the other parallel line and the transversal, do you see how they're forming angle 4? So angle 1 and angle 4 are another set of alternate interior angles. So angle 1 is congruent to angle 4 because, maybe I'll abbreviate this time, they are alternate interior angles. All right, so we've got those congruent angles. And we can see that those angle congruencies are already marked. Here's angle 2 congruent to angle 3 and angle 1 congruent to angle 4. Another thing we have is, by the way, here's where this is heading. When we put in this diagonal, we are creating two triangles. Right now, those triangles have two congruencies in each triangle. Both triangles share side BD. So we also know that BD is congruent to itself. The thing that lets us say that BD in one triangle is congruent to BD in the other triangle, that's that reflexive property. So we have congruent triangles. this triangle right here is congruent to this triangle right here because we have two angles in the included side. That's your angle, side angle. So I guess we're doing kind of a little unofficial proof here. Triangle ABD is congruent to triangle CDB, and that was from angle, side angle. So why are we even talking about all this, right? We're supposed to be talking about the lengths of the opposite sides. Well, through having some parallel lines and creating two triangles with that reflexive property, we've got that congruent side, you have congruent triangles. When your triangles are congruent, all the corresponding parts are congruent. So when the corresponding parts are congruent, that means that side BC will be congruent to side AD. Those are corresponding parts. So here's how we're getting to the sides, the opposite sides of a parallelogram. So BC is congruent to AD. We also have side CD that is it's a corresponding part to side AB. So what did we just say? CD is congruent to, we would have to say AB. And all of those two opposite sides are congruent from CP, CTC. But that's kind of the goal that we were getting to, is to be able to say something about the opposite sides. And now we can say opposite sides are congruent. So that leads us to our opposite sides of a parallelogram. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So if you have a quadrilateral where opposite sides are parallel, that makes this a parallelogram. Then that means that your opposite sides will be congruent.